keep it awesome technology.
What's up everyone, welcome back to the channel and to a new video, a quarantine video. When it comes to PC hardware, I'm always used to overclock basically everything, and this story goes on since 1993 when the first Pentium Cpus came around. And it has always been great fun until my previous chip, the Intel i7 8700K, so Coffee Lake, which I was able to overclock stable on all cores at 5.1 GHz. Now, as you probably saw from my recent video here, I passed to AMD, so I went for 3900x. And honestly, I already knew I wouldn't be satisfied by its overclocking capabilities, since it's well known that from the first generation of AMD Ryzen chips, they are not at all famous for their overclocking capabilities and possibilities. But after a while, I realized I had to approach the overclocking on the Ryzen chips a little bit differently, so with a different strategy than I always used in the past. If we also look at the 1700X, so the first gen, it was really good for overclocking. In fact, the most lucky ones were able to overclock those chips to maybe 200 MHz more, so not really a big deal. The good thing is anyway the introduction of the new Precision Boost Overdrive, which is a kind of game changer. So this functionality, together with the auto overclock, is able to grant you a pretty decent overclocking, only if you had a good cooling system as well as good voltages, and basically without any particular tweaking in the various settings in the BIOS. So it's not really totally automatic, but you don't have to do everything manually, let's say. So this option obviously helps in getting higher core speeds depending on the workload, but it's not on all cores, obviously, just some of those. We will see the example later on. The alternative is obviously the old way of overclocking, so changing the multiplier, CPU multiplier and the CPU vcore in order to get higher frequencies on all cores and threads. With the third generation of Ryzen CPUs, like my 3900X for example, there is something new to consider: the CCD, so Core Chiplet Die. For more information about that, I suggest you look at my review of the 3900X here, and it will provide you some additional information. But let's say that these are basically two separate dies communicating via the Infinity Fabric. Depending on the silicon lottery, there are chances that one die is more lucky than the other one, obviously, in terms of overclocking, and therefore this makes the things a little bit complicated in case you are going to go for an all-core overclocking. Another important aspect is to consider, so talking about the Infinity Fabric, is the ratio 1:1 with the RAM. So basically there is always need to have a 1:1 proportion between your RAM speed and your Infinity Fabric, so they should be always set at the same speed if possible. But this is currently possible only until 3600 MHz. So if you are below that, that's fine. In my case, I have 3200 MHz memory, which is more than fine for overclocking and for getting great speed and performances in gaming too. In this video I will also skip memory overclocking, since the gain between 3200 and 3600 MHz in RAM speed is not a huge difference. Obviously you will probably notice some changes, particularly in gaming, in case if you play at lower resolutions, but after all, not really a big gain. Moreover, my G-Skill RAM here doesn't have a B-die, Samsung B-die, but it's Hynix, so the gain wouldn't be so tangible. What is probably beneficial and good to do is to optimize a little bit the timings of your memory, so leaving your memory at stock speed, but trying to play a little bit with the timings and reduce them at the lowest possible value. But this might result in increasing voltage of your DRAM as well as in some errors, so intense testing with mem test, for example, will be also needed. With the test I did here, since I have 4 sticks of DDR4 G.Skill Trident Z RGB, that you can also check here in the review. They can only go up to 3333, so not really a huge performance boost. Something that I suggest to do before starting memory overclocking is always to try to get the most stable overclocking configuration of your CPU first, because by increasing the RAM speed and especially the Infinity Fabric, that will affect also your CPU overclocking capabilities. As I mentioned earlier, with the Ryzen CPUs, it's very important to keep the system quite cool, since if we are going to proceed with an automatic overclocking and BPO, that will affect how much the single cores will boost, basically. So what I did as a starting point, I started the usual way. I always overclock, so like on Intel, getting the speed on all cores at the maximum level possible by increasing the vcore as well as the multiplier. And this is fine in case you need the maximal multi-threading speed possible, since this kind of overclock will affect all cores. Anyway, after several tests and usage on different scenarios like photo editing, video editing, gaming, 3D modeling, I came to the conclusion that the best way, at least for me, was to have auto overclocking and precision boost overdrive, going together with the maximum possible optimization of the temperatures and in particular of the vcore, so the voltages in general. So follow me, let's look in the BIOS the different 2 methods of overclocking, my settings. So this will be obviously done on the Asus TUF X570 Gaming Plus, for which, by the way, you can check the review here. But the process behind, the logic behind is basically the same for all BIOS and all vendors. There might be some little changes in the naming, but mostly that's it. Okay, we are now in the BIOS, in the main menu. Let's go through the settings here. So basically, first thing to enable is the DOCP, which is basically the XMP profile here. So in this case 3200 with XMP timings. Performance enhancement enhancer here, I set it on level 3. Memory frequency and the FCLK, so this is the Infinity Fabric. As I said, they should be set at the same speed. So 3200 MHz DDR4 will be in reality 1600 MHz. So the same should be set also for the Infinity Fabric. CPU core ratio, we leave it on auto, since we are now going through the overclock settings on BPO. Okay, CPU core ratio, we leave it as is. Overclock tuner, keep current settings. Then we can go into precision boost override, we want to enable that. And also the max CPU boost of clock override available, which is 200 MHz. DRAM timing, so as I said, you can tune a little bit all the settings here. You can use this tool that I will link anyway. It's very useful and will give you all the suggestions you need in order to do RAM overclocking. Let's move on to the next section. So here we want VDD-CR CPU current capability at 120% with 200 here, switching frequency. Power phase control optimized, in case not stable we can go also on to extreme. And then I changed this value here for the SOC 110% and also again 200 here. Moving on the voltage, so in this case I used, as you can see, a negative offset. You need to do some test here, so the lower you go the better usually it is, but you shouldn't go very low, otherwise the system is either unstable or won't boost so much. So in my case here I went for a negative offset of 0.11250, which is basically what you reduce from the default voltage, CPU core voltage, which is 1.35. I did the same also for the SOC voltage. As you can see, we have a negative offset here as well. The RAM voltage depends on your RAM. This RAM goes default at 1.35. I pushed to 1.36, no big deal. I left everything on auto, but it's usually good to set this manually as well. So 1 volt here, 1.2 here, and so on. Okay, and these are all the main settings. Now let's move on to manual overclocking. So all overclocking all cores at 4300 MHz. So we can see this as the old way of overclocking, basically same settings here, with the difference that we are going to change manually the core CPU core ratio. So 43 in this case, but you can also go further in case your CPU is quite lucky, let's say. Maybe a safe value to start with is 42, and then you can increase after checking. So another change is the CPU core ratio. In this case we set it manually, as you can see. So for this kind of CPUs, for the Ryzen 3rd generation of Ryzen chips, is suggested to not exceed 1.325 volts as vcore. So that's the maximum I entered here, and then we want to have all the CCX units set at 43, as I'm showing here. Next thing to change is the PBO. So in this case we want that disabled. DRAM again, same as I said initially. Then we go into this section here where we want to have a load line calibration set at level 2 with 110% and 200 of CPU switching frequency. Then regarding the SOC load line calibration, so the LLC should be set at level 3 with the 120% and the 200 switching frequency. Again, an offset mode set this time only on VDD-CR CPU voltage. And everything else is basically as I mentioned earlier. So in both cases I left the C state on auto, as you can see here. So they're both, it's auto on both cases. In this case this will help in order to reduce dynamically the CPU frequency when the CPU is in idle or at low load. That will help temperatures, power consumption, and also the life of your CPU. So now let's back into Windows and let's do some benches, and let's see how these two different methods of overclocking will differentiate.
Do you think I want this? Don't stop.
Let's now look at the recap of the screenshots you just saw. With the help of some charts, we're gonna compare the two methodologies of overclock, manual overclock of all cores at 4300 MHz and auto overclock with the PBO. We will be starting with some productivity benchmarks. Every test was ran twice and with the same settings. Higher scores correspond to higher performances. You're now looking at the scores with all cores set at 4300 MHz. Now let's see in the same test how the other overclock methodology performs. So with PBO we can immediately see that we lose something in Cinebench R15 multicore, but we gain something in single core. Why? Because with PBO on, few cores grow at higher speeds, reaching up to 4600 MHz in high case. With Cinebench R20, which makes intense use of multi-threads calculations, we have a big drop in performances of about 300 points. I was expecting worse performances also in video and photo editing, but as you can see, DaVinci and Photoshop scores are aligned. Now let's proceed with some gaming benches. Here I expected to have higher scores with PBO, and we can see that in 5-track stream we have a small gain over the manual overclock of course, but in Time Spy we lose a few points. Doom Eternal in 4K shows exact same performances, while Assassin's Creed Odyssey 4K we have a gain of 2 FPS with PBO, and there are much more frames rendered in the benchmark. So the Valley benchmark runs at 1080p, so I expected better performances since it shouldn't be GPU bound at that resolution. Nevertheless, we see same performances. Same performances also in Shadow of the Tomb Raider 4K. Same FPS, but more frames being rendered with the PBO. Now, the final chart will show the maximum temperatures recorded during all these benchmarks, as well as the average maximum temperatures. We can see how more efficient is the PBO methodology over the manual overclock in terms of temperatures and also in terms of power consumption. Before ending this video, I would like also to share with you some comparison on benchmarks I did with my previous i7 8700K compared with this 3900X, in order to give you some additional background on the different scenarios and where, let's say, the single-threaded operations will benefit of higher clocks compared to multi-threads at lower stock clock speeds. So I hope in this video you learned something new, or at least I hope it helped in order to speed up your overclocking process and finding the best settings in the BIOS. And let me know in the comments below in case you were more lucky than me, or you were able anyway to get higher clock speeds. After all, there is always need of some luck, as we are talking about silicon lottery here as well, apart from other variables. As usual, don't forget to hit that like and subscribe button in order to support me with these videos. And thanks for watching. I'll see you in the next one.